Okay guys, let's demonstrate the difference between chemical and physical sunscreen molecules and how they work using everyday items, a sponge and some water. Let's imagine that this sponge is a sunscreen active and the water is UV light. Now this sponge sits on top of the skin, ready to absorb UV. This bowl over here represents what happens with a chemical sunscreen molecule, and this bowl over here is what happens with a physical sunscreen molecule. Are you ready? Let's go. Now imagine this sponge is a chemical sunscreen molecule ready to absorb the energy of the UV. As it absorbs, these molecules get really excited and they release the energy of the UV sun. As they do, they actually turn into other molecules, also known as chemical breakdown products. Now these chemical breakdown products are completely different than the original molecule. As you can see, there's blue water accumulating underneath the sponge, and pretend that this blue water are these other chemical actives accumulating in the skin. These photometabolites can be irritating or harmful to our bodies, and in fact many of them are considered unknown. There are over 300 different photometabolites that are formed after UV is exposed to a sunscreen molecule, and we only know and can characterize about 49 to 50 of them. Okay, now let's demonstrate what happens with a physical sunscreen like zinc or titanium dioxide. As the UV hits it, it absorbs the same energy and maybe reflects a little bit, but after it releases the UV light as thermal energy or radiation decay, it doesn't change to any unknown byproducts. So as you can see here, the water below the sponge is perfectly clear, representing the fact that the physical sunscreen molecule is in essence cleaner and not forming these potentially harmful other chemical products. After seeing this, are you team chemical or team physical? You decide.